So now that we have a good understanding of what permissions are, now we're going to look into how we would actually manage and change permissions on files and directories. And the command that we're going to use for that is called, well, it's pronounced CMOD, but it's really just short for change mode. And in Linux, you can kind of think of the word mode and permissions as kind of the same thing. If you're changing the mode of a file, it's pretty much the same as changing the permissions on a file. But before we actually get into using the CMOD command to manage permissions on files and directories, first we're going to kind of talk through and explain the octal method of managing permissions on files and directories versus the symbolic method. So as I said before, the CMOD command basically means change mode. And we talked before how there's basically three different permissions, right? There's read, there's write, and there's execute. And in previous classes, if you're familiar with counting in binary, we know that we count in binary from right to left in powers of 2. So we start with 1, then we go to 2, and then we go to 4. And so the way that we represent these read, write, execute permissions for the user, the group, and other is using octal. And to derive the octal number for each set of permissions, basically you just count in binary. Now we're going to break it down here, but after a while, you really will just get familiar with knowing exactly what octal numbers relate to which permissions. So for instance, if we were trying to set, let's go through all the different combinations of permissions that we can get using read, write, and execute. So if we have a 0, 0, and a 1 in binary here, that value is going to equal 1. And if we match these permissions up with each number, we can see that 1 is basically execute. So that would equal no read, no write, but execute. 0, 1, 0. That is equivalent to 2, which equals no read, yes write, no execute. 0, 1, 1. That is the decimal number 3, which equals no read, yes write, and yes execute. Now we need the number 4. For the number 4, we have a 1 here. 0, 0. That is the number 4. And that equals read, no write, no execute. 5 would be 1 here in the 4's place, 0 in the 2's place, and a 1 here. That is 5, which equals read, no write, yes execute. 6 would be 1 in the 4, plus 2 is 6, nothing in the 1's place, and that would be read, write, no execute. And 7 would be our highest number with a 1 in all 3 places. That is a 7, which equals read, write, and execute. So hopefully this isn't that confusing if you're familiar with basic counting in binary. But what we do is we basically use this binary counting method to derive at an octal number. So one of these numbers here is used to actually set the permissions using CMOD. So for instance, if we wanted to set the permissions for the user to read, write, execute, well, read, write, execute is 7. So we would say CMOD (7) and say the group permissions. We wanted to set the group permissions to just read and execute. So read and execute is 5 in octal. And then say we didn't want to give any permissions to other. So no permissions, we didn't really write it on here, but I'm sure you could assume that 0 is equal to nothing, nothing, nothing. So 750 would be equivalent to read, write, and execute permissions for the user. 5 would be equivalent to read and execute for the group. And 0 would be equivalent to no permissions for other. And then here we would just put like our file name. And that's how we would change the permissions on a file or directory using the octal method using CMOD. Now the symbolic method is a lot more easier, but both have their uses. So let's look at, let me get rid of some of this here. Okay, so the symbolic method you can use basically is like this. You started off with either a U for the user, a G for the group, or O for other, or a for all, which means user, group, and other. And then for the permissions, well, then we have an arithmetic sign in the middle, and that arithmetic sign can be either plus, minus, or equal to. And this basically means add the permission, remove the permission, or set the permission equal to. And then we put the permission of either read, write, or execute. And so to show you kind of an example here, we could say CMOD, let's say user plus execute /file. And what that would do is that would add the execute permission just for the user to /file. Now let's say we said G minus W. That would remove the write permission. If we said O equals tac, 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 that would essentially set it to where O or other had no permissions whatsoever. Let's say if you ever do basically just say CMOD plus X, which you'll see people do quite often, what that does is that basically is equivalent to saying A